ne-Go Digital SA Foundation. Siyathemba nizolijabulela lolu hlelo.
Sanibonani bafundi. Sesihlangene futhi ku-physical sciences. Namhlanje sobe sikhuluma nge-photoelectric effect. I-topic yokugcina vele, question yokugcina kwiphepha lakho le-final, photoelectric effect. I-topic nje elula kodwa inama-challenges amancane kumele uthi wagabe masidila ngayo. Photoelectric effect, it's a matter and material. Sibuka ukuthi the optical phenomena, right, of matter. Bese sibuka ukuthi yini esidila ngayo kahle kahle lana masikhuluma nge-photoelectric effect. I-photoelectric effect ihambisana ne-light. Into siyaziyo ngisayifunda mhlawumbe grade 10 or grade 11 siyazi ukuthi i-light is a wave. So that's what we know. Kodwa ke siyazi ukuthi beside ukuba i-wave, light futhi ne-property yokuba i-particle. So sikhuluma nge-dual nature of light. Kusho ukuthi light can behave as a wave noma ingabehave as a particle. Might behave as a wave, siyazi ukuthi sokhuluma ngani nge-speed, sikhuluma nge-speed, sokhuluma nge-frequency, sokhuluma nge-wavelength, sokhuluma nge-period, yonke leyo nto ehambisana nama-wave, sokhuluma ngama-wave equations, right? So masibuka ngale ndlela siyazi ukuthi you can have a wave, right? So you have a situation like this. Behloko fanele wazi makuthi une diagram emi kanje, gada ukuthi khonani kuma x-axis, right? Kuma x-axis makuthi unesikhathi, it means time. Kusho ukuthi mawusuka la uza la, like the distance between two consecutive points that are in phase. Lokhu kunika into esibiza ngani nge-period, ngoba kunesikhathi ngala, right? But kungenzeka kube nani, kube ne-distance. Uma kune-distance, even though i-wave will have the same shape, a distance from one point to the next that is in phase, ngala ngoba sine-distance la in meters, then leyo distance will represent what we call the wavelength. Lokhu kuhambisana masikhuluma ngani nge-light as a wave, right? States nani sine speed. Kodwa ngiyazi ukuthi light it's an electromagnetic wave, right? Uma kune electromagnetic wave siyazi ukuthi speed se-electromagnetic wave in a vacuum 3 times 10 to the power 8 meters per second. Asikhulumi nge-speed se-sound like kwi-Doppler effect, but sikhuluma nge-speed of light, of an electromagnetic wave. And leso speed say light was referred to as c. C wakhona, that was 3 times 10 to the power 8 meters per second. That the speed of light in air or in a vacuum. Njengoba sine speed kusho ukuthi kune frequency, makune frequency kube ne wavelength and kune period as well. So ama-wave equations are still applicable. Siyazi ukuthi speed is equal to frequency times wavelength. Le formula siyayazi. But njengoba speed si constant, right? Ngoba to 3 times 10 to the power 8. Kusho ukuthi singabuka i-relationship yani frequency ne wavelength. Iso siyazi ukuthi the-frequency and wavelength, they are inversely proportional. Frequency and wavelength. Kusho ukuthi frequency is inversely proportional to wavelength. Maku increase a wavelength, kuya decrease a frequency and vice versa. Right? So the higher the frequency, the shorter the wavelength. Right? That's what singakwazi ku apply yonke into as information kwi-wave equation. Okunye sikwazi ukuthi a relationship between a frequency and period. Period is t, right? So siyazi ukuthi frequency is 1 over t. the frequency was expressed in hertz, and then you have a wavelength in meters, and speed will be in meters per second, right? That is for the wave nature of light. So ukuthi maku it behave as a wave, siyakwazi ukuyibuka in terms of refraction, in terms of diffraction, and so on, as a wave, right? Mese ke kuba leyo part ukuthi light can also behave as a particle, right? Iyona vele zosilethela ukuthi sithole effects of light as a particle kwi metal, kuma electrons, then sokhuluma nge photoelectric effect. But before size lapho asibuyele futhi kwi wave as a light, sibona ukuthi masikhuluma nge light sibona kanjani I light, ngoba I light hamsana ngani ngembala, and each color represent what? A certain frequency. That the light will be represented with colors, and ama colors sasikhuluma ngani ngo ka grade 10 khulume ngo Roy G Biff, just ukumemorize kahle that R umele red, O umele orange, Y umele yellow, then G green, B is blue, I is indigo, and V money violet, right? These are colors in the light spectrum. It's no red, it's no orange, followed by orange, it's no yellow, green, blue, indigo, and violet. So mawukhuluma ngo Roy G Biff uzokhumbula kahle. Then into fanele uyazi ukuthi masuka from red siya ku violet kwenzekalani in terms of frequency. Kusho ukuthi singacomparisha frequency ka red ku frequency ka yellow as the color. So into siyaziyo masithi Roy G Biff kuya ngoku increase kwe frequency, increasing frequency. So singathini ukuthi orange une frequency enkulu kuno red, yellow une frequency enkulu kuno orange, and so on and so on. So violet une frequency enkulu kunabo bonke, increasing frequency, right? That's what we have. And siyazi futhi ukuthi maku increase frequency, the relationship between frequency and wavelength is inversely proportional. So singakhuluma ngoku increase frequency noma sithi decreasing wavelength, kya depend ukuthi wena ufuna uyibuka ngayiphi indlela, uyibuka ngo frequency noma uyibuka ngo wavelength, right? So singakwazi comparisha lama colors, masithi sino blue, sino red, sesiyazi ukuthi blue une frequency enkulu kuno red, red une wavelength enkulu kuno blue, right? So the one with higher frequency has a shorter wavelength, right? So that's it. Meseke njengoba sesikhumbulile lokhu, it was just a reminder. Asibiyeleke kwi particle nature of light, ngoba sikhulume kakhulu nge wave nature. Now masikhuluma nge particle nature of light, kusho ukuthini? Ukuthi a light masibuka ngathi inama particles, lama particles lawo they contain what? Energy. Kune energy etholakala kephi kwi light. Now leyo energy leyo idependela ukuthi leyo light ine frequency engakanani, right? So leyo light, leyo amount of energy esinayo kwi light sibiza ngani? Nge photon, right? So this is the first definition ungayithola ku exam to define what is a photon. Night define futhi ka grade 10 what is a photon. A photon is simply what? A quantum or a packet of energy found in light, right? A quantum of energy found in light, right? yona ebizwa ngani nge-photon, right? Noma ungakhulumi nge-quantum uzothi the packet of energy found in light, right? So kusho ukuthi i-light ifika nani, ifika iphethe i-energy. Now leyo energy, that's what I was described as a particle, ngoba it moves, right, from one point to another. When you have a beam of light, kusho ukuthi leyo beam of light inama photons, and each photon carries what we call a certain amount of energy. Now leyo energy leyo uyakwazi ukuyicalculator, moyicalculator ihambisana nani ne-frequency. Remember futhi i-frequency ihambisana ne-color, njengoba sikhulume ngo red or yellow or orange and so on. So i-frequency izohambisana ne-color, right? So njengoba sithe from red to violet khona increase in frequency, so singathi ukuthi energy carried by a violet light inkulu kune energy carried by i-orange, simply because i-frequency ka-violet inkulu kune frequency ka-orange, right? Emva kwalokho sibona ukuthi how can we calculate leyo energy. Leyo energy was given as E is equal to H times F. E is equal to H times F. E umele leyo energy of a photon, the energy of a photon. Mese kuba H. H is a Planck's constant. Planck's constant. Constant is just a value that will be given. Planck's constant in a value of 6,63 times 10 to the power negative 34, right? Joules second. That is the value of Planck's constant. 6,63 times 10 to the power negative 34. A constant, right? Mese kuba nani? Kuba ne frequency gego, F frequency, and the frequency it is expressed in hertz, right? So your formula, your color, energy of the photon will simply be calculated using this formula. Kusho ukuthi mabone unesibalo kuthiwa calculate the energy of a photon with a frequency, let's say 500 hertz, right? So mase kuthiwa what is the energy, usebenzisa leyo formula uthi H times F, then uyathola leyo energy that correspond to the frequency. Kahle into usinayo lana a frequency, but ungamona kuma questions bangakuniki direct i-frequency kodwa bakunike mani i-wavelength, kodwa usakhumbula ukuthi how i-wavelength and the frequency they are related kwamisana ngani nge-speed. Then when you get the speed, ngoba speed uyasazi valid speed of light was 3 times 10 to the power 8, and Planck's constant uyamazi, kusho ukuthi you can simply manage le formula. So ngesinye isikhathi ungabona ukuthi usingakwazi kumanipulate ayo formula ethi E is equal to H times F, kodwa siyazi ke futhi ukuthi C is F times lambda. Lambda umele wavelength, so masenza frequency abe subject of the formula, kusho ukuthi F uzoba C over lambda. Masithatha lo C over lambda kuyi frequency simulethe la, right? Replace lo F by C over lambda, sithola ukuthi soba no E is equal to H times C over lambda, right? Now into enye futhi ukuthi uyakhumbula ukuthi u-H i-constant nalo C now constant. Now mawubuka le formula uzobona ukuthi kahle ngoba lo constant kusho ukuthi le energy kahle idependela kubani, ku-frequency. So singathini, the energy of the photon is directly proportional to the frequency, right? So that it. Masibuka le formula esibili umona ngokuthi u-H constant no C also a constant, kodwa uyabona ke u-H lambda is with denominator, kusho ukuthi when you increase the wavelength the energy here decrease, and it's making sense ngoba siyazi ukuthi i-frequency ne wavelength they are inversely proportional. So into soyibona ukuthi singathi ukuthi the energy of a photon is inversely proportional to the wavelength, right? So mhlambe kuthiwa asathe isibalo esisodwa kuthiwa calculate the energy of light wave with wavelength mhlambe just an example 5 noma sithi 50 nanometers, nakunikezwa ukuthi 50 nanometers. So into siyithola la ukuthi sinikezwe mani i-wavelength, kanti yazi ukuthi uma calculate i-energy udinga mani i-frequency. So ngoba sine wavelength siyakwazi ukuthi with the wavelength we still can calculate i-frequency. Kodwa ke i-wavelength uyabona ukuthi sinikezwe in nanometer, it's not in meters. So in that case kumele senze njani? Senze i-conversion ukusuka kuma nano kuya kuma unit sithi times 10 to the power -9, njengoba kusho nano 9, right? Then makuthi kuma micrometers sithi times 10 to the power -6, right? So kulombuzo singasebenzisa E is equal to H times C over lambda straight. Then sizothi H as Planck's constant 6,63 times 10 to the power -34 times C 3 times 10 to the power 3, bese siya divide ngo lambda sinikezwe no 50 nanometers, so kuzoba 50 times 10 to the power -9, right? Message sithola ukuthi ithini leyo energy. Siyazi ukuthi energy is expressed in joules, right? So faka ke 6,63 times 10 to the power -34, let's see times 3 times 10 to the power 8, this is here divide ngo 50 times 10 to the power -9, right? So the energy esinayo ithi 3,978 times 10 to the power -18 joules. Your energy that will be produced by a photon of light in a wavelength of 50 nanocoulomb, right? Noma mungafuna ukuyahamba ngaleyo ndlela ke ungaqala ucalculate i-frequency ekuyafana. So uyazi ukuthi C is frequency times lambda. C uyamazi 3 times 10 to the power 8. Awudingi uyi-memorize le number uzonikezwa yona as kuma data sheet. Sidinga frequency, wavelength esinikezwe yona 50 times 10 to the power -9. So lana sithola ukuthi frequency will simply be 3 times 10 to the power 8, all this divided by 50 times 10 to the power -9, kusinika 6 times 10 to the power 15. So frequency yethu ithi 6 times 10 to the power 15 hertz. Iyona frequency yaleyo light corresponda nobani no 50 nanocoulomb, right? Mese after sesithole i-frequency sidinga ucalculator i-energy. I-energy sasakhumbula ukuthi energy ithi H times F. H i-Planck's constant 6,63, njengoba ngishilo awudinga ukumemorize, it will be given times to the power -34 times 6 times 10 to the power 15, right? So khiphela bona 6,978 times 10 to the power -18 joules. Ngiyathemba ukuthi siyayibamba ke lapho, right? So leyo energy ke asenze ukuthi senze application yayo, njengoba sithi i-light ihamba ne-energy, iphethe energy esibiza ngani nge-photon. Now i-photoelectric effect kwayona sibona ukuthi masi describe as a process. It was found that when there is a metal surface, that's in a metal here. Siyazi ukuthi metal as an object or as an element or a matter, it has ama protons nama electrons. Sakhumbula nge metallic bond naga grade 10 naga grade 11, right? Ukuthi how ama-protons ama-electrons are. You have the localized electrons. Kusho ukuthi maningi ama-electrons unawo lana kule metal, right? But uyazi ukuthi ama-electrons, they are not connected to a specific proton, njengoma non-metals, right? So you still have ama-protons, but you look at these electrons, the localized electrons. Kutholakala ukuthi ma une-electron, uyazi ukuthi electron is connected or very attached to a proton. Kune-energy ebambayo. Then, mase kufika i-light ezoshayina kule metal. Angisiyazi ukuthi le light mayishayina kanje, it has i-energy. So if it strikes le electron, le electron, then i-energy yale electron izoyenza njani? Izonyuka. Makunyuka electrons, energy electron, siyazi ukuthi electron izomove away from layer proton. Na kungenzeka ukuthi i-energy that is gained by this electron ibe enough ukuthi i-electron ize ifike la kwi-surface of the metal, right? Kusho ukuthi le energy eyitholile is enough ukuthi isuse kule proton yakhe ukuthi ize ifike la. Then emva kwalokho mayithola i-energy enkulu futhi kungenzeka ukuthi le electrons iphume, right? Ibe ejected from the metal surface. Now, njengoba kuphuma i-electronic, then siyazi ukuthi asikwazi ukuwaluza lama electrons. Masifaka intambo lana, an electric conductor, what will happen? Lama electrons lawa azohamba through that electric conductor, right? So we just channel them some way, right? We electric conductor. And ngoba kuma electrons, sazi ukuthi makuna a flow of electrons kwi conductor, that is an electric current, right? Yeah, ngifuna ukuchaza ke i-photoelectric effect. Yabona ukuthi kwi-photoelectric effect sidinga i-metal. Then kube khona i-light, incident light. Le light ifika nani? Nama-photons. Lama photons aphetheni i-energy. Makuthi photon mayishaya i-electron, leyo electron izobamba leyo energy. Masiyibambile leyo energy izoyisusa leyo electron next to i-proton iyise kwi-surface of the metal. But makuthi leyo energy sayiningi kungenzeka ukuthi lama electrons aphume completely, move away from the metal. Leyo process leyo iyona ebizwa ngani nge photoelectric effect. So singayidefine ngokuthi photoelectric effect is a process whereby electrons are emitted from the metal surface when a light of a suitable frequency shines on it. Right? The photoelectric effects. Photoelectric effects is a process. Likhama lithi process lizosiza njengoba sakhuluma nge photoelectric effect. It's a process whereby electrons are emitted or ejected, are emitted from a metal surface, when light of suitable frequency shines on it, right? Shines on it. So now you define a little, so ungasebenzisa ngisho amagama akho as long as you have the keyword. Fana ukhuluma ukuthi it's a process, ndoqala leyo, mase uyakhuluma ngokuthi ama-electrons azosuswa kwi-metal. That's the other keyword, right? Kwi-metal surface, the surface of a metal, ama-electrons azosuswa khona. Why asuswe kwi-metal? Ingoba kune frequency, kune light of suitable frequency that shines on it. Then that will be described as photoelectric effect, right? Njengoba sichaza njenge process ingoba kunama stages. Yabo mase kufika i-light ifika ne-energy, leyo energy siyakwazi ukuyi-calculate, right? Mese kuba i-metal kwayona. I-metal inama-electrons, ama-electrons ane-energy yayo, but mase ama-electrons athola leyo energy iqhamuka kwi-light, kusho ukuthi lama-electrons ane-energy eningi engakwazi ukuyisusa kule metal. Then uzobona ukuthi each metal ine amount of energy that will be needed. Mhlambe mangisebenzisa metal magnesium, uyazi ukuthi magnesium angeke ifane nani ne-sodium noma ifane ne-copper. So uzobona ukuthi the way i-metal is attracted kuma-electrons is different, ngoba siyazi ama-chemical and physical properties of a element. That's why they are even in different groups and different period. So uzobona ukuthi ine-energy uzoyidinga mhlambe kwi-magnesium ayangeke ifane ne-energy uzoyidinga for i-sodium, right? Kungenzeka futhi ukuthi le light mayifika mhlambe lama-electrons athole leyo energy, but leyo energy ingabe enough ukuze isuke kule metal. So lapho asikhulumi ngani nge-photoelectric effect. Noma le energy efika ne-light enza ukuthi i-electron isuke kodwa isale khona kwi-surface of the metal, we still don't talk about i-photoelectric effect. I-photoelectric effect mase kuhlangene i-light efika ne-energy, lama-electrons akhona kwi-metal mase phuma futhi, then sisakhuluma ngani nge-photoelectric effect. So we have three energy esokhuluma ngayo. The first one is the energy of the incident light. Kune energy la, and siyakwazi ukalculate ethi H times F. Lama electrons mase suka kule metal, they move with a certain speed, right? And siyazi ukuthi khona energy define as the energy an object has due to its motion. Leyo energy sibiza nge-kinetic energy. So kusho ukuthi lama electrons lawa mase suka kule metal aphethe i-kinetic energy. I-kinetic energy so ibiza nge-K max. I-formula kinetic energy ayishintshe, ihlezi i-half mv squared. The v is the speed of the electrons, m is the mass of the electrons. So the mass of an electron 9.11 times 10 to the power negative 31 kilograms. Yoni mass electron, right? So you still have this one. And so you understand ukuthi sine energy yoqala ifika ne-light, that the incident light, kodwa ke emva kwalokho mase kuphuma ama-electrons now ahamba nani ne certain amount of energy. So kufika leyo energy le efika ngayo, but ke kune part yesithathu le ephakathi nendawo. Kumele ukuthi le energy ezofika ne-light ibe enough ukuyisusa i-electron next to its proton ilethe la kwi-surface, right? Mase kudingekala i-extra energy. Leyo extra energy iyona ezosusa ke electrons away from the metal. So kusho ukuthi le metal nayo inani ine a certain amount of energy, the minimum energy ezodingakala ukuze ama-electrons aphume kwi-metal. Ngoba le light mayifika ne-energy encane vele ama-electrons they will just be excited kodwa angaphumi kwi-metal. And sithe in that case asinayo i-photoelectric effect. So i-electric effect izoyenzeka only if ama-electrons have been able to be removed. Manje leyo energy ezodingakala for that particular metal, a minimum energy that kumele ukuthi ifike nayo leyo light ukuze ama-electrons akhishwe kule metal. So ibiza ngani nge-work function. I-work function, right? I-work function. I-work function now it's an energy. So they find out ngokuthi it's a minimum energy. It's a minimum energy required. Minimum energy required for an electron to be ejected from a metal surface. So the minimum energy kusho ukuthi le energy ezoqhamuka kwi-light makuthi ayifiki kule value le yale energy, then ukuthi no photoelectric effect will take place. Then ngithe ukuthi la minimum energy idependela ku type of metal that you have, njengoba ngike example e-magnesium angathi ne-sodium, because metals don't have the same physical and chemical properties. I-work function so inika i-symbol W naught, yona i-work function. It is energy, it is an energy actually, right? So siyabona ukuthi sesinama energy awu 3. Khona le energy efikayo ne-light ithi E, bese kuba nale energy edingakalayo for i-metal sibiza nge-W naught, bese kuba leyo energy akuzohamba ngawo ama-electrons, right? Sibiza ngani? EK, kinetic energy, right? So we have those 3 types of energy kuleyo le process, ingakho ebizwa nge-process ngoba ufika no E bese kwenzeka W kuphuma bani u-EK maximum, right? So uzobona ukuthi makuhlanganisa EK nalo W naught fanele kuskiphele bani the energy of the photon. Lama electrons lawo asuka asesuswe kwi-metal siwabiza ngama photoelectrons, right? Ngoba asuka kwi-metal because of ama photons, right? So each photon will correspond to 1 electron. So mawuthi akwazi calculate the number of photons kusho ukuthi you ngathola ukuthi nama number of electrons that passed what a point, right? So iyona ke i-photoelectric effect. Kumele kube i-light, incident light, energy enkulu kuno W naught, kune work function. Ukuze mase kune extra energy, leyo extra energy izosetshenziswa ukuthi ama-electrons akwazi ukuphuma, akwazi ukuhamba, akwazi ukunyakaza, ngoba mangena energy awakwazi ukuphuma. So le energy ingakho sithe a suitable frequency, ngoba siyazi ukuthi masikhuluma nge-frequency sikhuluma ngani? Nge-energy, right? Now kule formula lo E is equal to H times F, uyabona ukuthi sidinga i-frequency as well. So singakhuluma ukuthi le energy sinayo, is it enough, is it greater than the work function? Kodwa le energy nayo ihamba nani? Ne-frequency. Kusho ukuthi masithola le energy ifanele siyazi ukuthi leyo frequency le which frequency ezohambisana ne-frequency ezoskiphela ama-electrons. So we need also another frequency ehambisana nani? Ne-work function. Leyo frequency so ibiza ngani? Nge-cut-off frequency noma i-threshold frequency. I-threshold frequency, right? I-threshold frequency. Monga ibiza nge-threshold frequency, ubiza futhi ngani? Nge-cut-off frequency. So we define exactly the same way you define a work function. Umehluko ukuthi instead of energy uzofaka bani? Uzofaka i-frequency la. Kote definition isayona. So a cutoff frequency is simply what the minimum frequency required for an electron to be ejected from a metal surface, right? So definition eyoto maso uwazi ukuthi work function udila ne-energy, ufake energy la. Mawukhuluma nge-work the threshold frequency, ufake frequency la, right? Then you have everything, right? Now njengoba sikhuluma ukuthi it's a frequency, kusho ukuthi lo W naught as the energy, now singamcalculate njengani? Njengele energy efikayo from the light, right? Singathi ukuthi W naught is equal to H times F naught. H times F naught. And lo E siyamazi nayo ukuthi H times F. EK is half mv squared, right? So then we have three stages kule process. Stage 1, sino stage 2, bese kuba ne stage 3. Stage 1 is the incident light. Incident light ifika ne-energy u-E. Their energy is contained in light over H times F. Stage 1 kwenzeka lokho. Then le energy le efika ne-incident light ifanele ihlanganise i-energy ezosusa i-electron from its proton ilethe kwi-surface. Then makune extra, leyo extra iyona izoyenza ukuthi i-electron inyakaze imove away from the surface. So stage 2 sina W naught, i-energy nayo futhi, and siyazi ukuthi energy is Planck's constant times frequency. The frequency that we have here ibizwa ngani? A threshold frequency. Then stage sokugcina or stage 3 so ukuthi ama-electrons ayahamba, ama-photoelectrons njengoba enyakaza kusho ukuthi anani i-kinetic energy. So sothi EK maximum uzothi half mv squared. This is the third energy. Kusho ukuthi kahle kahle le energy yokuqala iyasplitwa between these two. Ifanele i-overcome le energy yokuqala bese uthola-ke i-energy la. Right, so this energy here must be equal to the sum of the two energy. Now, le energy le constant. This energy here is constant ngoba idependela kwi nature ye metal, the nature of the metal. Bese kuba ke lo le energy EK maximum. Le kinetic energy yona ayikho constant, kuya depend ukuthi kungene energy engakanani. Lana ku incident light it's not constant also ngoba ungashintsha i-frequency. Mhlambe kade usebenzisa i-blue light uvela usebenzise i-red light noma usebenzisa u-yellow light, yabo lama colors lawo azoshintsha ini i-frequency. Makushintsha i-frequency kushintsha nani ne energy. Kodwa le light kumele i-overcome lo work function ukuze kutholakala i-energy extra, iyona izokwenza ukuthi kuphume ama-electrons. So kahle kahle egcineni udinga ukuthola isithini speed salama electrons. Ispeed sama electrons dependela ukuthi i-energy in excess engakanani. Right, ukuba in excess kudependela ukuthi kungene i-energy engakanani ngala lokhu nokuthi kumali ku-energy engakanani as well as for i-work function. Right, so masihlanganisa ke lama lama energy sothola ukuthi energy incident energy ikunika bani i-work function plus EK max. This is the formula for a photoelectric effect. Right, so ungayi unpack-a ke u-E umenze abe u-HF, u-W naught umenze abe HF naught, u-EK max abe half mv squared. Right, lo m ngithe i-mass ye-electron. I-mass ye-electron it's a constant, awudingi uku-memorize futhi ngoba uzonikezwa yona, it's 9,11 times 10 to the power negative 31 kilograms. Right, most of the time azokushela ukuthi calculate bani i-speed noma kinetic energy yama photoelectrons. Right, now kwi test fanele wazi ukuthi they can ask you umbuzo mhlambe la kuthiwa calculate ngala. Now umbuzo uzokunika information ku stage 1, bakunike mhlambe ne-information ku stage 2, kusho ukuthi umbuzo bazokubuza into ku stage 3. Noma bakunike information ku stage 1 bakunike information ku stage 3 bazokubuza umbuzo ku stage 2. Noma bakunike ku stage 2 no stage 3 then umbuzo ube ku stage 1. It's always like that. Right, now it's all a matter of understanding ukuthi le formula isebenza kanjani. So ma unalokho then you know i-photoelectric effect usuyibambile, uyakwazi ucalculator speed sama-electrons, noma uyakwazi ukuthola ngisho ni-work function uyakwazi ukuyithola, noma uyakwazi ukuthola bani i-threshold frequency. So it's always about this one, uyalana usuka la uza la, right? All right, then into singayenza manje mhlambe singabuka ukuthi si-unpack kanjani le formula, ngoba mase sihlanganise konke u-E ubani H times F, lo uzoba H times F naught, then la kuzoba half mv squared, still the same formula. Kodwa into ufanele ukukhumbule ukuthi out of zonke lezi zinto u-W naught le part le stage 2 le constant. Stage 2 is constant. The work function of a metal does not change. The work function of the metal does not change. Kusho ukuthi mokuthi le i-constant, singaboni relationship between the energy of the incident light ne kinetic energy of the electrons. Njengoba siyazi ukuthi constant la kuyasho ukuthi masi increase i-energy of the incident light, ngoba lo constant kusho ukuthi ne energy yama electrons, yama photoelectrons izo increase. That's what we can say it is directly proportional. The speed of the photoelectrons is directly proportional to the incident light energy. That the energy engenayo, and then you can do the correct thing. Right, mhlambe sibuke isibalo esodwa noma i-application ye photoelectric effect. Now, i-photoelectric effect ngoba ikhipha ama-electrons, lama electrons lawo azosetshenziswa as an electric current. So ukuthi kahle sine source of electrical current ezokhiphela ama-electrons. Sisebenzisa kwi-device esizoyibiza ngani nge-photocell. Photocell. Structure se photocell is just something in a metal, then something like this, right? Then mhlawumbe ungafaka i-ammeter ngala ngoba sithe ama-electrons ayaphuma, then we can have a setup engine, right? Now, more a setup engine, this one is a photocell. Nati metal ela. So this one will be the metal. Is over in a cathode. Right now, light is oshaya la. So externally, this one is connected to a positive. Then you have the negative this side as a battery. Right. Message shaya lana. Ukuzopuma mani ama electrons. If this light is having enough energy, it's a suitable frequency, kuzopuma ni ama electrons. Nangama electrons are kishiwe due to the fact that the energy of the incident light was greater than the work function, yale metal plate. Then lama electrons awana direction into zenike direction. Ile battery le esifake nje ekugcineni si-connector nale electrode. Yabo kule electrode lama electrons, there is an attraction between the positive and the negative. Wonke lama electrons azozala ahambe kule ntambo. Then we create what? A flow of electrons. A flow of electrons ibiza ngani? Nge-current. We have a current that have been produced. La ile phenomena bayisebenzisa for a solar panel. Nabona ama solar panel. The solar panel use what? Photo cells. Right? Njengoba ufaka nje ilanga lifika nani ne energy. Leo energy zokhipha ama electrons. Then ama electrons azohamba kuna ama conductor. Then you have what? A current that is being produced. Right? Now, lama electrons la are produced kayo adipendela into ezimbili. The first one is speed sayo ingakana noma amount of ama electrons. Now, the light that shines in ama properties out too kungaba frequency noma kube intensity. right? For the incident light, incident light. Two things esingayikhuluma ngayo about incident light. The first one, sikhuluma ngani nge-frequency, and the second one sikhuluma nge-intensity. Right? Intensity into ifana nokuthi kukhanya kangakanani, like the brightness. Yeah, sikhuluma nge-brightness. Light mhlambe makuthi it's blue, right? We have a blue light. Leyo blue light ine-energy ine-frequency engashintshi. Then you can have blue ekhanya kakhulu nenye ephinde ekhanya kancane, but you look at the brightness. So masikhuluma nge-brightness, i-frequency ayi-affecteki. Kodwa masikhuluma nge-frequency, mhlambe sishintsha lo blue sifake u-green, i-frequency siyashintsha. Now, how will the frequency affect the current produced, or how will the intensity affect the current that will be produced? Now, kuma electrons, kuma photoelectrons, we look at two things as well. The first one is the speed. Sitini speed sama photoelectrons. Secondly, sibuga kuti number of photoelectrons. Right. So we'll see how these two frequency, the incident light, will affect the speed of the photoelectrons. So the first thing is it masibuga frequency. Frequency kahle yona izo affecta any energy. And siyazi ukuthi maku increase leyo energy kusho ukuthi njengoba u-W0 u-constant, kusho ukuthi kuzo increase nani ne-kinetic energy izo increase. And kinetic energy masin apeka kinetic energy uhambisana nani ne-speed, kusho ukuthi ne-speed sama electrons sizo increase. So if you increase the frequency of the incident light, the speed of the electrons will increase. Right? So if the frequency of the incident light decreases, then the speed of the photoelectrons will also decrease. What will happen to the number of electrons? The number of electrons won't change. Kuyafana makuthi bephuma ama electrons awu 17 zophuma still awu 17. Umehluko ukuthi lawo ane frequency enkulu azohamba na ne speed esikhulu as compared to the other one. So the number of electrons remains constant. That is the effect of frequency on speed of photoelectrons and the number of photoelectrons. So if frequency affects speed. Number of electrons, it's not affected. It remains the same. Only the speed that will be affected. Then, sibuge intensity. Intensity, sort of brightness. So makuthi light green, it remains green. Kusho ukuthi frequency yakhona ayishintsanga. So if I have E mangi increase brightness, E awunyukanga, kusho ukuthi njengoba no W0 constant, kuyasho ukuthi no EK will remain constant. By increasing brightness, the blue light doesn't change it to become green. It's just the brightness, right? So E, as it remains constant, nalo EK, kinetic energy, will remain constant. Kusho ukuthi speed will also remain constant. So uma increase the intensity, if speed sama photoelectrons will remain constant, right? Then what if asibuke manje a number of photoelectrons? Yazi ukuthi ma ukhanyisa kakhulu vele brightness, a greater surface will be covered by the light. But the small amount, the dimmer light will cover just spaces nani. So that surface a cover ishegile ngaleyo light is ukipela vele ama electrons amancane. But if you have a higher, a stronger, a brighter light, it will cover a bigger surface, and a bigger surface means what? A greater number of electrons. So the number of electrons will be affected by the intensity. It will be affected by the intensity. But the speed will remain the same. Kota maskuluma nge frequency. If frequency increases speed, kota number of electrons remains the same. So loko singa ku transfer ku external circuit ya le photocell. bazokubuza ukuthi how will the ammeter reading change if you increase the frequency noma if you increase the intensity. Ma increase frequency ngoba ama number of electrons awashinjanga kusho ukuthi no effect will be observed kwi ammeter ngoba ama number of electrons did not change. Remember, current is defined as the rate of flow of electrons. You still have the same electrons ukuthi lana ahamba nge-speed kodwa the numbers were still the same. Nisakhumbula vele formula ethi I is equal to Q over delta T. Q lo lokuza ngani o representa ama electrons. So if you did not change Q, then the current will remain the same regardless of the speed that you have, right? Then masine intensity. Ma increase intensity, speed sama electrons remain the same kodwa azophuma emaningi kusho ukuthi lo Q uzo increase. If Q increases, I will increase. So by increasing the intensity of the incident light, the current will also increase, right? So the ammeter reading will increase. So you can use that phenomena in that way, right? So in local, as in photoelectric effects, and then if you can explain how the frequency will affect the speed and the ammeter reading and how the intensity will also affect it, then we covered kule topic. Again, zobuyela kumani kuma stages of the process. Ingakho si define photoelectric effect as a process. Kuna stage 1, stage 2, stage 3. Bazo uyabo ku stage 1 mningi mbuzo engaphuma la ku stage 1. Mhlambe kuthiwa calculate the frequency, noma calculate the energy, the incident light, define the photon and so on. Ku stage 2 thina umbuzo ngaphuma mhlambe define work function, define threshold frequency and mhlambe calculate work function. Then stage 3 bangakutshela calculate speed, right, sama electrons, right? So advice ukuthi nithatha ama question paper, past exam papers, nimbuke to the topic, nenze some exercise. Then so bonana ke next week again. Siyabonga for ukulalela kwenu, and sibuye sibonane ke futhi same place, same time.
Siyathemba ningakhohlwa ukuthi nisengathokozela ezinye izifundo eziyisithupha kanye nezengeziwe i-learner wellness, i-career guidance kanye ne-advanced program. Hlanganyela nathi kwizifundo ezi-online ku-068 151 1072 noma ku-GoDigi@godigitalsa.today. Siyabonga.